for tomorrow. Okay, so we'll start our next session. Our speaker for next section, Dr. Lalit Singh, sir, is available here. So I would like to invite him into this stage, and I would like to tell about his profile. So Dr. Lalit Kumar Singh received his PhD degree from IIT, from Indian Institute of Technology, BHU. He is currently scientist and head of artificial intelligence applications in NPCIL BARC Department of Atomic Energy, Government of India, and has distinction of working on pressurized heavy water reactors and light water reactors. He has an illustrative career and succeeded in jobs assigned to him in his career. Through each of them was challenging. His assignment over the years ranged from design, development, testing, related research, and site validation of the safety critical computer-based systems of Indian nuclear power plants. He has published several research papers in journals of high impact factor like IEEE Transactions, ACM, IEEE Computer. He is a senior member of IEEE and a member on advisory board of IEEE Industry Relations and Entrepreneurship Committee. He has been invited for chief guest keynote speeches, session chairs, and talks in many international conferences, workshops, and faculty development programs from many IITs and NITs and other institutes of national importance. He is a recipient of many awards like prestigious IEEE K. Sankar Award, Publication Award, Group Achievement Award, etc. He is a reviewer of several SCI index journals of high impact factor. He is a life member of Indian Nuclear Society. He is a founder member and industrial coordinator of the proposed Center of Dependability at IIT BHU. He is in the panel of Faculty Assessment Committee for Department of CSC, IIT Roorkee, to access their research profile and give recommendation. He is an expert member of Industrial Policy Formation of IIT Ropar. He is a reviewer and project collaborator of research proposals of Board of Research in Nuclear Sciences. He is also faculty of Nuclear Training Center, Department of Atomic Energy, Government of India. He is interfacing with other countries like Russia, USA, France, etc. for importing nuclear reactors that are based on new technology. So far, he has completed 33 projects of Department of Atomic Energy, Government of India. He holds 520 rank in India in the list of world scientists released by EDI Scientific Index. So I would like to welcome sir to deliver his lecture today. It will be on AI application in nuclear power plant. Thank you.
You can open slide. Okay. So, very good afternoon to all of you. And thank you. First, I would like to thank all the organizers who have given this opportunity to share some of my experience. And so today I'll be uh, talking on artificial intelligence applications in nuclear power plants. So because nowadays we see like there are a lot of applications that are coming up which are based on artificial intelligence because of the benefit that the society is getting with respect to the predictive analysis and lot of like other sustainability metrics. So this session, if you look into the agenda, so I'll be basically discussing applications of artificial intelligence nuclear power plant. So because the nuclear power plant I have taken as a case study, so first I will be introducing what actually the nuclear power plant is, what are the major components of the nuclear power plant, what is the working mechanism of the nuclear power plant, because when you will be able to understand the working mechanism, you will be able to appreciate the various cases which can be based on the AI. So then, this could be the one vertical talking about the nuclear power plant, another vertical that I will be touching on the introduction of the AI, and then we can try to uh, club those two verticals. uh, And there I will be discussing the various AI use cases, and we can conclude uh, with discussions with any doubts. Okay. So, what is the nuclear reactor? I'm sure you might have gone through the nuclear reactor with the nuclear energy since, like, your intent when you were studying about the neutrons and how the neutrons is giving the energy, right? So basically, the nuclear reactor is designed. It is a kind of device which is designed to produce the chain reaction. And how it produces a chain reaction, basically. Uh, okay, so first, why it produce a chain reaction? Because it can produce the steady flow, or it can the, produce a steady flow of the neutrons generated by the fission of the heavy nuclei. So what happens like uh, there are a lot of like heavy nuclei. Like if anything is heavy, it has a tendency to break. For example, if there is a plastic ball, if you throw, it will not break. But if you do have a very heavy stone, if you just drop it down, it will break into two parts. So the heavy nuclei has a tendency of breaking it, breaking automatically, right? And that is known as the spontaneous fission. So what actually the fission is? The breaking of the nuclei into more than uh, one nuclei is known as a nuclear fission. And then once the nuclear fission takes place, it releases a huge amount of energy, that is 220 million electron volt of energy. One nuclear chain, one chain reaction. So in the nuclear reactor, what happens? Because there is a heavy nuclei, we use material as fuel. For example, heavy nuclei materials could be uranium, could be thorium, could be plutonium. These have a properties which has its nuclei very heavy, and it has a tendency to undergo the spontaneous fission. It means it has a tendency to split by their own. So when it splits, it generates two or more nuclei, and in one reaction, it generates 220 million electron volt of energy, right? And now, and it also generates 2 to 3 neutrons, sometimes 2 neutrons, sometimes 3 neutrons. So on an average, 2.5 neutrons in one fission reaction. So one fission reaction, I repeat, it conclude what actually it is. It creates more than one nuclei or radioactive components, plus 2 to 3 neutrons, plus 220 million electron volt of energy. Now, these neutrons becomes the source of creating the new fission reaction. So one neutron will be the source of creating one fission reaction. So what happens when one neutron will be striking on the uranium nucleus? It again create a chain reaction. So, and in the chain reaction, again, it will release the two radioactive elements plus 220 million electron volt of energy plus 2 to 3 neutrons. So you can see like one reaction can introduce three chain reaction because one neutron is responsible to create one fission reaction. In every reaction, we are getting 2 to 3 neutrons. So again, in the second iteration, it will create like 3 into 3 reaction. So in that way, you can see like the number of the chain reaction takes place. The fission reaction keeps on increasing. Every reaction also we know like 220 million electron volt of energy is getting released. So once the number of fission reaction will be increasing, you can understand how much energy, huge amount of energy is getting accumulated. This nuclear reactor maintains the steady flow of neutrons because because the neutrons now is responsible to create a chain reaction. Otherwise, it can become the nuclear bomb if I'm not able to control the amount of the energy that is being released. Because every time the the neutron population is getting increased. So I need to regulate the neutron population. There are various means. Once we will be discussing about the working mechanism of the nuclear reactor, we'll be seeing how we can do that. So it is basically maintaining the chain reaction in the sense but how many number of neutrons should be there, it is maintaining that. So it is indirectly maintaining the chain reaction. Okay. Uh, or the another definition you can see like it is an apparatus in which heat is produced due to nuclear fission chain reaction for the generation of the electricity. We will see how we can generate the electricity. Okay. Uh, so this is a typical diagram of the nuclear reactor. Let us see how our nuclear reactor basically works. So if you are able to see, I think the pointer is not working properly. But anyway, if you are able to see this block, okay, this is a rectangular block having rounded corners. This is known as a reactor core, okay, which the neutron or in which all the fission reactions are taking place. Fission reaction that I was just talking about. Okay. So here, all the fission reactions are taking place, and you can see like there are a lot of thermal energy is basically getting created. Fine. Now, I and you can see like so here the number of neutrons will uh, will keep on getting created. And there should be some means where I can regulate number of neutrons. So you are able to see like these are the vertical strips, the red colors. I'm talking about the red colors, which are hanged by the metallic string and having the clutch. So the clutch and the clutch has the regulation due to which the immersion or the metallic string height can be altered. So these are the red strips are known as control rods. So why these are known as control rods? Because it has a property to eat the neutrons. So it can control the neutrons. So generally it is made up of cadmium or boron, because which has a property which can, absorb the neutrons, or which can eat the neutrons, right? And depending on how many neutron populations should be inside this core, I can change the level of immersion of the control rod. Because it is hanged with the metallic string, and each metallic string can control the level of the control rod to immerse into that. So here, basically in this area, the reactions are taking place, and this area, the neutrons are basically taking place. So I want to suppose the control the number of neutrons in this area. So I just need to, push all these two control dots down, and these control dots can be, pulled a little up, because here I don't want to control. I don't need too much control. Depending on, uh, the neutron density in, it should be uniform all the zones. So it is divided into mini zones basically. Here just I have shown the pictorial representation. It is a representative figure, but its size is very huge. Okay. So these are generally divided into the various compartments, various zones. So in which zone I want to control the nuclear, control the neutron population, I have to change level of the immersion of the control rod, and which can be changed because it is connected by the metallic string, and which is connected to the clutch, and that can be controlled, so the metallic string can be pulled or pushed, right? Can be pulled up or can be pushed down. Fine. So here we have understood how um, the neutron population is being controlled. And as I said, here a lot of energy is getting accumulated, because in every reaction, 220 million electron volt of in thermal energy is getting accumulated. So if I'm not able to uh, take out the heat, so this is a thermal energy, right? I need to transfer that heat. Otherwise, what will happen? The container which is contained that energy may get jeopardized, because a lot of, the temperature is almost 3000 degrees centigrade, and maybe your component is not designed enough. Or but definitely I need to, but the other thing is I need to transfer this thermal energy into the electrical energy. So, like energy can be transferred from one form to another, right? So, what happens like, there is a pipe, okay? So it contains, there is a one inlet and one outlet. Okay, so this is a reactor vessel which contains one inlet and one outlet. And in the inlet, I need to pump in the cold water. So cold water means then it has a good capacity to take out the heat, right? So this is the one pipe, and I have not shown the internal pipe. It is a integrated pipe basically. So when the outer surface touches with that pipe, having temperature of around 300,000 degrees centigrade, then the outlet water becomes very, very hot. Its temperature becomes very hot, almost 300 degrees centigrade. 3000, the temperature of here could be the in the range of 3000, but here that water that is coming out will be in the range of 300 degrees centigrade. Okay. Like the boiling point of the water is 100 degrees centigrade, and after that it starts becoming steam, right? But here, why the water is which is coming out at the 300 degrees centigrade is not converted into the steam because it is pressurized water. Once you increase the pressure, you can change the boiling point of the water, right? So I have so this is basically in a very high pressure zone, and hence this water of 300 degrees centigrade is coming out, and this component is known as steam generator. So it generates the steam as the name specifies. Okay. So what happens like in the steam generator, the it contains the logical compartments. Lower compartment contains the water, and the upper compartment contains the steam. Now, how this water gets converted into steam? So the water that is coming out, having the temperature of 300 degrees centigrade, in this pipe, when it touches this water, which is at the atmospheric pressure, it is not the pressurized water, suddenly gets converted into the steam, right? Because we all know like water needs like, it starts getting converted into the steam at 100 degrees centigrade. So, because it gets converted into the steam, and because steam has a lighter density, so whatever that has a lighter density, it gets accumulated on the top, top portion. So it is all the steam is getting accumulated on the top portion over here, right? And once it transfers the heat, then again this water becomes cooled down. So, but I cannot throw that water because ultimately the temperature is the energy. So I had to again recycle it. And again, this is a closed loop and infinite loop, which keeps on exchanging the energy and keeps on, converting the water into the steam in the steam generator. Okay. And now what is happening basically? This is steam, because steam has a lot of enthalpy, like the total energy. Enthalpy means the active energy and the latent energy. Okay. So it has, it can drive the shaft of the turbine, steam turbine, and which is connected with the electrical generator. So it rotates the shaft of the generator that will produce the energy which can be connected to the consumers, to the grid. Right? Hmm? And now all the steam is not getting, all the steam energy is not utilized to drive the shaft of the turbine, because the steam, some steam is non-saturated steam and some steam is saturated steam. Saturated steam is what? Which is a dry steam, means which does not contain the moisture. So it contains a lot of enthalpy, and that can be used to drive the turbine. And which is non-saturated steam, it means which is a wet steam, so that can come down, and then this part is known as condenser. So like what is the condensation process? So when any hot thing touches the cold surface, it basically condenses. It gets liquefied. Okay. So that steam, which is a non-saturated steam, when it touches the cold surface. So um, this pipe basically, when it touches in this pipe, it converts into the water again. Okay. And here, basically, the cold water is flowing from here. it is a cold water. There could be some water reservoir. Either it could be the river, it could be the ocean, or it could be some, self-made, like I'm creating a source of water. Okay, so it the cold water can be pumped in, and when it touches this cold water, it gets converted into the liquid. And again, this will be the closed loop because this contains, although it has been converted into the liquid, but it has a good amount of temperature, and we don't want to waste it. So again, I loop back into the steam generator, and which can again be used to create the steam. Got it? So this is the secondary loop basically. Okay, and this is the open loop, tertiary loop, where the cold water is getting and coming in, and it gets converted into, it will become warm water because it is, the steam is striking over here. But if it is taking from the ocean, the warm water needs to be checked with respect to the temperature so that it should be ensured that all the water bodies inside the ocean, like fish or other water bodies, should not die, should be sustained at pressure. So there are a lot of, quality checks, and we have to control the temperature of the water which is being released into the ocean. Okay, to maintain the uh, water bodies. So this is the entire uh, working principle of the nuclear reactor. And if you are able to see, like these two components and into a confinement shell. So there is a, like, which is made up of concrete, because these are particularly very high radiation environment, because here the nuclear chain reaction is going on, which is creating, each nuclear fission reaction is creating uh, two or more radioactive elements, and which is basically which is a highly radioactive components. Okay, so we have to ensure like those radioactive components should not be released to the into the public domain, and hence it is closed into the confinement shell, so, which is a very is the civil technique, because in the confinement shell, it is designed such that internal pressure should be slightly negative than the atmospheric pressure, so that from the outside the things can comes in. If some leakage is there, for example, if some leakage is there, but nothing can go out from here. Okay, so it is slightly kept into the negative pressure. Okay, because we know like pressure, moves from higher pressure to lower pressure. Okay, and yeah, so this, because this is very closely connected to the steam generator, so steam generator also, covered into the confinement shell. Fine. So this was the one vertical I had discussed. I hope you all understood what is the working mechanism of the nuclear reactor and what are the various components of the nuclear reactor. And now we will be seeing like how what kind of artificial intelligence applications could be built up, which can give a lot of benefits. So first, let us try to understand what artificial intelligence or machine learning is. So I hope that because the workshop is on related to the AI. So in the first lecture, I hope you could have got the flavor of artificial intelligence, right? So anybody can tell what artificial intelligence is. What do you mean by, yeah, please. Okay. Okay. Anyone else? Yeah. Is design of intelligence. Okay. Mhm. Okay. Mhm. Mhm. Okay. And what is the machine learning? What is the difference between artificial intelligence and machine learning? Is can you speak little loud? Which gives you? Okay. Yeah. Okay. Mm-hmm. 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 Okay. 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 Yeah. So, but okay. I mean, I got all the answers are partially correct, but let us see like what actually it is. So, okay. First, let us try to understand the machine learning. What actually the machine learning is. So, the machine learning has been inherited with the concept of the human learning. Okay. So, suppose there's a newborn baby. Okay. And you know, like the newborn babies, they are more curious to learn many things. They are more curious to explore new things, right? So suppose, okay, the newborn baby is sitting in his mother's, mother has taken the newborn baby, and for example, suppose she is also taking a cup of tea also. Okay, so generally, you would have seen like a general behavior of the baby, like he will try to hit something, like and many times like they get burnt also. So suppose that baby hits to a cup or touches the cup, and he like it got hurt. Then next time onwards, he will try to like understand from his past experience, like, okay, this was the shape of the cup, and this was the style where mom was taking the tea, and definitely it will it can again hurt me, and he may not touch it, right? So basically his mind gets trained from the past data. A lot of data basically he has seen, and he has inferred something. Fine. Okay, but there could be some error also. For example, uh the next time, if she's taking the cold water, suppose, in the same cup, and when that baby is not, touching that, thinking like, okay, last time I got burnt, but his prediction becomes wrong, right? So why its prediction becomes wrong? Because he might have missed something. So it all depends, like, if probably if that baby is more smart, then what he could see, like, he can distinguish with one more factor, that, okay, in the earlier one, some vapors were also coming up when there was a hot tea. And the cold, like, he is not able to observe that vapors. So it all depends basically on how smart the baby is. But I'm talking about the training process basically. So suppose the next time he touches, for example, if he's more curious, the next time he try to touch, okay, when vapor is not coming, okay, let me try to touch it. And next time he see, okay, now it is not hurting me at all. So you can visualize, okay, so it means anything that if the vapor is coming out, it may be hot, it may hurt me. Either it could be the tea, it could be the water or something like. Okay, so it is inferring from his behavior and is the data and the data, right? So this is the learning basically. Why? Because in the human brains, there are a lot of neurons. Basically, millions of neurons are there, and daily lot of neurons dies and lot of new neurons takes birth. Each neuron is what? One neuron contains the some memory and some processing power. Each neuron. So suppose I do have one neuron, I have one part of the information. The other neuron has other part of information. So all these neurons are interconnected so that the memory and the processing could be shared, and the processing speed can also become fast because one neuron has a very small processing capacity and very small and very limited number of memory as well. All right. So those are connected with each other. So one information can be input to the other neuron. So the output of one neuron could be the information, could be the input information to another neuron based on which he try to compute something and he gives some output. Probably that output may be the input to the other neurons. Okay. And the share and the memory also gets shared, and ultimately, like the final one will be taking a decisions. And that is a reason, as I told you, the neurons, because of the neurons, daily lot of neurons takes birth and lot of neurons dies. Many of the things we forget also. Why? Because if suppose 5 years back something has happened and I'm not recalling it continuously, and that neurons might have died. So the information have not propagated to the near neurons because you have not recalled any time, right? But you are recalling, something. It always remain in the backup of your mind, and you cannot forget it basically, right? Because those neurons might have transferred you know, uh, their information to the another neurons, which are the new neurons, like that. So if repeatedly you are recalling something, you may not forget. Okay. So this is a kind of the training that is being or the training process that basically happens in the human being. Okay. And the same thing, the same philosophical approach has been inherited uh, for the machine learning as well, because it is a human learning and that is a human is just replaced by the machine, right? So, so in the machine learning, if you look into what actually the thing we need to do, it is a data driven technology, right? So everything I learned based on the data. The experience is what? It is a data. So this thing was happened, that thing was happened. It's a data, right? So we have to gather the data first, and you know, every there are a lot of ample of data, but it all depends like whether the data is context relevant or not. Context relevant in the sense for what is your objective, right? So you have to prepare that data. Okay, so you will have to filter some non-relevant data, which is not relevant based on your current context, right? So so that is why it is data preparation. It is known as data preparation. Maybe other data is meaningful, but it may not be relevant for your context. Okay. The second one is the third step is data wrangling. So if you collect the data, you can see like there may be many duplicate data may be also be happen, right? So you should remove that duplicacy. The reason is what you are going to do, what you are going to achieve with the duplicate data. If I have trained my machine that if you get X input, you have to give Y output. Now again, if I'm training with the same data, it is just wastage of the computation power. You are not going to achieve something. So you can remove all the duplicacies. You also need to remove some of the outliers. What are the data outliers? That is very important to understand. For example, uh, the body temperature ranges from suppose x1 to x2 degree centigrade. Okay, and I'm measuring it from the thermometer, and he's very much fit. And suppose because of the malfunctioning on the thermometer, it is sensing the temperature very wrongly, which is not possible at all. For example, 0 degree, right? So these are the outlier data, which are the faulty data, or which is not relevant. So you have to remove that data because otherwise, if you will try to train your model with those outliers data, your model will have error. Okay. So it will not be correct. So in the data wrangling part, you have to look into these aspects. You have to remove the outliers, you have to remove the duplicacies, and you have to then, after all these iterations, you have to then analyze your data. Yes, now this data is perfect. Why it is very important. The artificial intelligence, machine learning. First, let us talk about the machine learning. We'll come about the artificial intelligence. Machine learning is a thing where if you are giving input, the output is 101% guaranteed. But whether the output is useful or no, you cannot guarantee. It all depends on the quality of the input. And what the quality of the input is? Quality of the data. If you are giving the, you know, wrong data, you are going to get the wrong output. Okay, junk data, junk output. If you are going to give the quality data, the quality output. So because it's a data-driven technology, you have to take a lot of efforts to prepare the data which can be inputted into your model which you are going to train. Okay, so the fourth step is after doing all these steps, you have to analyze the data properly. Again, you have to ensure whether everything is correct. This is the perfect data. Then you have to give that data to train your model. Then you have to train the model. And once that is that obvious, once I come up with any kind of product, you need to test it. Okay. So you have to test a model. So generally in machine learning, suppose I do have X amount of data. I choose 70% of the data to create a model and rest of the 30% of the data to test the model. The rest of the 30% means in which some input output combinations will be there. I will be giving and saying, yes, it is predicting rightly, for which I have not trained rest of the 30% of the data. So in this way, I can ensure the correctness of my model, the reliability of my model. Okay. So I have to test the model, and once I get a good confidence on my model, it is giving the good predictions, I can deploy it. Or otherwise, I may have to step back to any of the steps, like whether the training, maybe the training of the model has not been taken place. You might have not used the good algorithms. You might have not designed the good algorithms, because algorithms also is based on on the type of the data. You might have not designed those algorithms. You might have not, missed something in analyzing the data. Probably the data is not, is still is not a good data. Okay, so there is a, once you, uh, big data is another subject where you can come to know, like, what is the quality data and non-quality data. So it's a kind of multidisciplinary domain, basically, where, the data science itself, you have to understand to create your data. Okay. Okay, so this is all about the machine learning life cycle. Okay. Now, if this is a machine learning, what is the artificial intelligence? So here I have seen, like, okay, it's like a dog. I have given some training and he was knowing, okay, if I was getting this input, I have to behave like that. Okay, so this was the output that I need to do. Just a moment. Yeah, sorry. Okay. Okay. So, this was a crude kind of training. Okay, you have just trained. For this, you have to do that. For this, you have to do that. You have not applied your own mind. But I was giving the example of the baby. Example, he had seen the vapors and he has applied some intelligence, kind of, and again he touches and take, this as a feedback to learn, to improvise his learning. So earlier, the learning was okay. This was the color of the cup, and that was the style of the mother who was sitting. And the next one is, after seeing more number of features or properties of smoke, he again tried and taken as a feedback. So he's continuously learning with the feedbacks, right? So artificial intelligence is nothing but machine learning plus feedback. So continuous improvisation of machine learning algorithms takes place from the feedback. Okay, so it keeps on learning from the feedback and it keeps on improvise its predictions. So the model will keep on, become more and more accurate as more kind of, scenarios. It can be trained with more number of scenarios. So that is the reason machine learning is the subset of the artificial intelligence. Okay. So I hope you all understood, like, what is the difference, what is the machine learning, and what is the artificial intelligence, what is the difference between two, right? Okay. So what actually happens now if you design any machine learning model? Now that was the concept base. Like I have discussed so far, I have discussed the concept. Now I suppose I want to implement it. So the input, it basically contains the input, the processing, and the output. Okay. So this figure, it contains the input layer. So each one ellipse is a neuron, which contains the processing power as well as the memory, and it is interacting with the other neurons. Okay. So this is the input where you have given some input. And, this is the output layer, and this is the model. Okay, which contains the hidden layer, which process that inputs. Based on the algorithms, it gives some output. Fine. So now you can, one interesting thing that you can notice over here is there are the two hidden layers. So a minimal machine learning model contains the two layers. One is input layer, one is middle layer, or one is output layer. But if the middle layer is more than one, middle layer is hidden layer. If hidden layer is more than one, so it means you require more processing power because one set of layer may not be sufficient to process the information which was receiving from the input layer. Okay. So you require more processing power. For example, suppose I want to select from this group, I want to select uh, the candidates from X university, right? So the first thing is I need to locate. Uh, I know like X university comes in which city. Okay. So first I may have to look like, okay, from where your registration from which city has been happened. So this could be the job of one hidden layer. Okay. The second one is I will look the particular name of the of your institution or what. So depending on you know uh, complexity and in the analysis, it may not only depend on the huge number of data. The hidden layers, the number of the hidden layers depends on the complexity of analysis of your data. Okay. For example, there is a very small data, but you have to apply so many filters. Okay. So definitely you have to assign that particular thing or role to one particular layer. So we may increase the number of hidden layers. So one thing now I want to introduce, when there is only one hidden layer, is known as the machine learning. So one input layer, one hidden layer, and one output layer. And it is more than one hidden layer. It is machine learning, but it is a deep learning because you want to understand the data. You want to do the deep understanding of the data, and that is why more than one hidden layer is required, right? So this is a kind of the deep learning. So I hope you understood now the difference between the deep learning also, deep learning, machine learning, and AI. Okay. Okay, this is a very important slide. Uh, convolutional neural network. So, uh, anybody has uh, or is aware of convolutional neural network, or anybody has heard about convolutional neural network? Hmm? Okay, what is that? Tell me. Mm-hmm. 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 So why it is required actually? Why this convolutional neural network is required? No. Why images only? Normal AI will not work on the images? So I need to process the data only, no? In the so. Mhm. So that can be applied by the use of filters. That should not be any problem. But okay. Mm-hmm. Mm-hmm. Yeah, yeah, yeah. Yeah, that is that. Yeah, yeah, correct. Huh. So, mhm. Right, 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 correct. So, what happens like the normal data, if I'm talking about, that is very small size in nature. And images are very huge size. The reason is to tell what is the image. What is the image? Can you tell anyone what is the definition of image? That is okay. I mean, so it is a matrix. Matrix, है ना? So image is a matrix having rows and columns, and the elements are the pixels. So it the elements are the pixels and which contains the pixel intensity. So if you talk about the binary image, only it contains the two values, 0 and 1. But if you contain the gray image, it can contain 0 to 255 values, right? If you contain the high dimensional color values, like it can contain 0 to 2056 or something like. Hmm? So contain nowadays, the images. These are the very high resolution images and very very high colored images. So it's each pixel uh, uh, data may range from 0 to 2056 and all. Okay, so it's a very high definition image data. So we cannot process that data using the simple AI algorithm. So for that, the convolutional neural network plays a very important role because such a huge amount of data needs to be processed. For example, if you look nowadays in the flights, the DG Yatra has been introduced. So in the DG Yatra, you don't need to do anything. You only have to just uh, enter into the in the front of camera, and automatically it will be you can bypass the security, right? So DigiYatra has been introduced in various airports, especially where the cities are very crowded. Mm. So this is all the application of convolutional neural network, right? So how it basically process? Uh, so the first layer is known as the input layer. Okay, so where all the images are given of the input. This the second layer is known as convolution layer. So what is convolutional layer? See, in the images, I cannot, as I said, for example, it's a big image, so it contains a lot of pixels. The rows and columns will be very much. I cannot process each and every pixel. It requires more very, very high computation power, very high computation power, which takes a lot of time also, right? So what I can do is I can only try to extract the important features of that image to recognize that image. I don't need to process each and every pixel, which is not possible at all. Okay. So I only the convolutional layer basically it extracts the important features from the image and it creates the feature map. Okay, so it creates a feature map or which is also known as the activation map. And it also contains the uh, rectified linear unit, that is layer. So why ReLU layer? Because generally the images are non-linear. Okay, so this ReLU function, it introduces the non-linearity into the image. How non-linearity? Because it can discard all the negative values to zero. So it contains the zero and higher values. Okay, and it is a non-linear function. For example, the sigmoid, it is a non-linear function because at one particular point it is non-differentiable function, because once you set all the negative values to zero, so one is horizontal line and then map. Okay, so at that crossing point, it is non-differentiable. Okay, and hence it is a non-linear function. So, so this is just to introduce a non-linearity into the image, and then there is a pooling layer. So what happens? Although you have extracted some important features from the images, but still you have to see whether those images can be reduced further. So to reduce the dimensionality of the feature, the pooling layer will help you out, and you may have to follow, or you may have to process these convolutional value and pooling multiple times depending on the nature of the image, the size of the image, and your context. Depending on the context of your problem, what you are trying to do. Okay. So in that way, it can contain and times, and then uh, there will be the softmax layer, which basically decides probability of identification of that particular image. That this is, see, if it is a 0.9 probability is that it is a rat, 0.1 probability it is a cat, like that. So it assigns the probabilities, and hence in this way the images are identified, and which can be, processed in the artificial neural network. Right? So that was the second vertical. With, the artificial neural network, we have seen what is a machine learning, what is artificial intelligence, what is the deep learning, what is convolutional neural network. These are the important, concepts. Yeah, and testing. Yeah, validation. Validation. There are the two concepts. One is a verification and one is validation. Okay. So, for example, in software, anything when you make, you have to go for the verification and validation. So verification is nothing. For example, here is a development. It's a kind of software development, and you have to follow the entire software development life cycle. Or suppose, yeah, validation comes in software engineering only. Mhm. Mhm. Validation is a part, testing is a part of validation only. Validation means you want to validate the data, for example, right? So you want to validate the data, okay, data is correct or no. So for example, if there is some outliers in the data and you are analyzing the data and you are seeing, okay, this data is not correct. So I have validated the data and I have discarded that particular data. So validation is nothing. The precise definition of validation is whether it is meeting the requirement, if a specification or no. For example, if I do have meaningful data, but the subset of that data is only relevant to my context of my problem. So the other data I will not require, I will discard, although this is a meaningful data. Now I have only taken the perfect data. This I have validated the data. Okay, for validation means now it is fulfilling my specification. So the definition says like, it you have to ensure like it is meeting with your requirements. That is a validation. Either it is a data validation or it is a process validation or it is a software validation. But things will remain same. Only the context like will be changed. See, the thing is, you have the context, you do have the real data. Ultimately, when you train the machine, you train from the real data, right? Or from the simulation data. For example, suppose in many of the cases, the real data is not available. I feel like I'm designing a system from the scratch in the nuclear, system. And that kind of system has been introduced first time. Okay. So I don't have the real data. I am using the simulation data. Now, from the simulation data, I know like because of I'm a system analyst, I know this data if it is using and this output it is giving, it means it is correct. So lot of system analyst, the data science, they basically the part of the project and they try to analyze the data, whether the data is correct or no. And that data is being given for the training. Okay, so data analysis, in the data analysis, because it is a domain sensitive also, so the system analyst also have to take an important role. Like for example, I know like the pressure of the or the temperature of the reactor core uh, may not be less than, for example, 1000 degrees centigrade, right? Because I know generally it remains around 3000 and somewhere in some zone it becomes 1000. If I'm getting 500, sorry, 500 degrees centigrade of the data, as a system analyst, I will come to know. Probably who is not from that domain, he will not come to know. So system analyst plays a very important role to prepare the data. And he knows if these are the inputs and these are the output. But why machine learning? Because for everything, like I want to replace the human intelligence, right? So I have understood, I have trained the model from the feedback. Again, I have, the model is getting improved. And after lot of perfection, then basically we deploy the model. So lot of training basically used to be given. And there is a context of overfitting the data or overtraining and undertraining. So underfitting the data. So sometimes what happens if you train your model with each and everything. For example, suppose you are having a child and you are teaching for each and every minute after. See, it will be overfitting. He will not be able to use its intelligence, or that maybe he will become a rule based. Maybe the other scenarios cannot be understood. So there's a kind of overfitting problem. So you overfitting cannot. It's a different, basically, out of the context of our discussion. And the underfitting is you are not training a model with respect to all the possible scenarios, like a very less number of scenarios you are giving. So it will not be able to train or it will not be able to give the good predictions for the real data, right? So that's a different context. Okay. So okay. Now let us try to understand the application of artificial intelligence in the nuclear power plant. So we all have seen the working principle of the nuclear power plants and what is artificial intelligence. Now, the first use case has taken digital twin, which is a very, very important use case, right? So you might have all in the newspaper and all, you might have studied uh, digital twin country. Even the Singapore is trying to create a digital twin of its entire country. So what actually the digital twin is? Anybody is aware of what is digital twin? Okay, okay. Actually, digital twin is creation of the identical system of the real entity, or creation of a digital version of the real entity. Okay, so digital, so means it is a twin. Twin, like twins are there. So it is one is a replica of other. Okay, so I want to create a replica of a physical object, and what could be the advantages of that? Maybe possible in the real object. I may not. I don't have access to each and every part of the real component, which I can analyze into the digital version to know more and more insights about the real entity, right? I can do a lot of predictions what is going on in the real object if I'm not allowed to enter, or it is not practical to go into that. For example, if I want to create a digital twin of the Singapore as a prime minister, I can see like what all activities are happening. I can't go each and every place and to see, but digital twin gives a lot of information at one end. Okay, all the activities, all the insights about the system. To understand the system in the holistic manner, so it can be used. It's a kind of, I mean, simulator can be a very subset of digital twin. So a lot of simulations can also be done, can also be carried out in the digital twin to understand the process, to improve the process, improve the design, right? To create the simulators, predict a lot of things, to know more and more insights about the system, and to predict or, you know, uh, overcome the limitations of the existing challenges. For example, if something lies in a very highly radiated zone, and I want to measure something like inside, and like in the real object, I don't have any access. I cannot access because of radiation zone. I can do that with the help of the digital twin. Good. Okay. Okay. So, but the creation or the development of the digital twin involves a lot of challenges. So, for example, in the nuclear power plant, I want to just create a digital replica of the nuclear power plant. This is a real entity, and I want to create a digital version of it. Okay. So, how we can develop the digital twin? So, we have to see what all the things we need to model. So first, I need to model all the physical assets. Physical asset could be different buildings, the reactor, like containment building, turbine building, control room building, administrative building. All the buildings I need to model. Clear? Physical phenomenon. What process is being carried out? How they are working? The physical phenomenon. Or suppose if any construction activity is there, all the physical phenomenon, like suppose workers are working, all those needs to be modeled, right? Now coming towards all the computer-based systems, what are the various sensors? Because in the real nuclear reactor, we do have lot different type of sensors. Some are measuring temperature, some are measuring level, pressure transmitters are there, level sensors are there, RTDs are there for measuring temperatures, right? Flow meters are there, meters, which are measuring the flow. So different type of sensors are there, which is basically capturing the data or sensing the uh, data from the real entity, and it is processing into the embedded system, and embedded system, from the embedded system it is giving to the operator interface unit to show, which can, because of that data we can see like whether the entire nuclear reactor state is safe or no. Okay, process parameters. So we have to model all the sensors. There are lots of sensors in the nuclear reactor. We have to understand the working of those sensors, and we need to model those sensors. We need to model the instrumentations, how those sensors are connected with each other. Okay, how the data is being transferred from one processing unit to another processing unit. Probably our sensors, maybe the smart sensors also. I have to model those sensors. And all the computing and networking systems, I have to model all the computing systems, all the networking systems, procedures and human actions. For example, if you might have seen the Chandrayaan, a movie, Mission Mangal movie, right? So there you might have seen the control room is there, and the things can be operated to launch the missile. Hmm? So the human actions are very important. They play a very important role. For if you are able to recall, the first time when the operator uh, gave the uh, signal to launch the missile wrongly, even their process parameter was not allowing, and just they wanted to launch the data, launch the missile, and they have given the input to the decision authority was this process parameter is fine. And ultimately that led to the failure of the mission Mangal. So operator actions are very important. The procedures are very important. And those procedures and human actions need to be modeled, right? So I need to iterate that each and every entity, the real objects, needs to be modeled depending on your context, right? Uh, and now, so these are the basically these are the collections, and how basically we have to do digital version of, or the creation of the digital version of that physical entity. The first thing is we have to uh, do the data and information management. So because there are a lot of data, the sensors, and all, like with these other computers and a lot of type of data. So we have to have a very good database management system. We have to categorize the data into the various segments, and accordingly we have to manage the data. We have to store the data, right? So some data is very safety critical data whose access is very limited and cannot be given to everybody. So access based, role based access to the data needs to be modeled. Some data is only for the information where I may not require to give any password, or any password protection is not required. All those things needs to be modeled here. So storage, sharing and accessibility, user interface and visualization, what data should be used for operator or for visualization, depending on the real scenario. And then we have to go for the modeling and simulation, where we have to do the data analytics, because we have to see like what data is relevant or no, and accordingly we have to prepare the data. We may have to prepare the machine learning or artificial intelligence models, and which can be trained from the physics-based models, because the reactor basically works on the physics-based models, right? If this is a pressure, this is a temperature, what will be the volume? So all those are the physics-based models or first principle models. And the results of those physics-based models can be used for machine learning training, okay, as well as the past data also. So those models you need to build, and data informed models also for data modeling, and other models as an you require. So all these models you have to prepare, okay, and then you have to connect it from the real. This digital version should be connected with the real all the time. Why? Because here now this created, but all the times I have to take the feedback from here. What is happening, so that I can keep improvising the training over here. Okay. So what information will flow? Data and performance information of asset information. If suppose new building has come, so that model needs to be again, improvised, or new computer has come, or new system has come, real-time sensor data, plant operation and management data. These should be information should keep on flowing. So it should always, the digital twin should be connected with the real entity all the time. And what advantages it can give? All the actions and recommendations, like diagnostics and prognostics. What is diagnostics? Find out the fault. For example, if some sensors are faulty, it can easily find out, which is not possible from the traditional mechanism, right? So it can, because it is directly based on the understanding the data pattern, and maybe that thing has not been stimulated uh, with respect to the traditional mechanism. So before that, it can give more good diagnostics. Prognostics means, for example, how much remaining life of a particular component is. That is known as a prognostics. Okay. So all those things which can be used for the spare management and all. So operation and maintenance recommendations, autonomous operations and controls, all these kind of recommendations and actions can be given by the digital twin. Okay. So I hope you understood this use case of digital twin. Okay. Hmm. Then this one is digital twin. Okay, so this is a real digital twin which has been made by the Metroscope company, which is a France, EDF France company. It's so like here, Bhava Atomic Research Center is responsible for carry out the nuclear business. In the France, EDF is responsible to construction, operation, maintenance of the nuclear reactors. Okay. So he created the digital twin. So in area France, almost there are 60 nuclear power plants that are under operation. And the root is, so in the secondary side means from steam generator to turbine. Actually what was happening, because of some internal losses, uh, there was some loss of the power, some internal leakages. So digital twin has come out with the conclusion that Uh, Actually, it should produce 963.5 megawatt of energy. But actually, it was producing 959.9 megawatt of energy. So there was loss of, almost 4 megawatt of energy, which is a very huge per day loss, right? Huge loss. So the digital twin was able to find out like where the internal losses were there. Like it identified that there is a tube rupture in feed water reheater. So feed water is which is feeding the water to the steam generator, because the steam generator is creating the steam. It is using the water only. So the water level comes down. So again we have to feed the water. So there was some rupture in the feeding that water. Okay. So there is one real advantage that has been seen. The third use case is it was used in improved reactor safety. So there was a European project, Cortex, and you know was the budget was almost 55 lakhs uh, euro. Okay, so this was a joint project of like many countries, so 20 from 11 countries across the Europe. Okay, so in the yeah, that that project was to monitor the uh, all the activities that is happening inside the reactor core, because it's a very highly radioactive zone, and in which the human access is not possible. So that was the project which is able to monitor what is actually happen inside the nuclear reactor, and how the neutrons are getting created, and what are the population of the neutrons, and how the reactions are taking place, and what all the radioactive components are being created, what is the radiation zone, what how many how much thermal energy is being created, how the control mechanisms are working, control rod mechanisms. So all those insights basically they are able to understand from that particular project. Similarly, this sensor of fault detection, because there are a lot of sensors, millions of sensors in the site, and I want to understand which sensor is faulty. Like so, the process is very simple. Like you collect the data, process the data, and you have to extract some of the features. Suppose this is a normal data, this is a faulty data, and then you can use the machine learning algorithm to understand which data is faulty data. Okay. So predictive maintenance. So this is also a real use case developed by the Rosatom, Russia. And like each emergency stop of the reactor is about 1 million euro loss profit per day. Okay. So this much of huge loss is there if I'm shutting down the reactor for 1 day. Okay. So emergency shutdown may cost you very high, and to prevent that, because because of the turbine, it has been seen there were a lot of reactor shutdown used to happen earlier. So they have come up with the predictive maintenance. So bef- before much, actually it is going to fail. It can predict like, okay, this component is going to fail, which can be taken for the repair for predictive maintenance. Flow accelerated conversion via rates, like because there are a lot of mechanical pipes, and you cannot monitor each and every pipe, but by understanding all the relevant process parameter, feeding them in the AI, using the relevant algorithms, and we can find, okay, this pipe is going to be corroded, and we can take the preventive actions rather than the corrective actions. So damage in the concrete structures, walls, like, and important walls, probably many of the walls are in the radiation zone. So I can also, because any damage in the concrete follow a pattern, so it can easily understand the pattern. So these all are the real use cases. So it is being developed by the EPRI California. Okay, so it has a lot of advantages. So what they do, they use the drones to collect all the image analysis data, and then use the convolutional neural network based AI models to uh, identify the damage in the concretes. So there's a prognostic analysis where I can find how much remaining life of a particular component is remaining, which can be used for spare management, right? So because many things are very costly, some, 30 crores, 40 crores. So why, suppose if I purchase the spare part, and which is not being used for a year, its lifetime will keep on deteriorating. So why to procure much ahead, before its use? So I can do a good spare part management by the prognostic analysis, which can be carried out using the machine learning algorithms. Error detection, like how it can detect where the human has done the error, and it can give the recommendations. This use case has been developed by Idaho National University, USA. And transient identification and operator disease support system. This has been developed by the BARC for loss of coolant accident and main streamline break scenarios, where the operator decision support system is developed, and it is tested on high-speed computing facility at Reactor Safety Division of BARC. Okay. So it was an Indo-UK joint project, and the conclusions is are very good. And then robotic solutions, in various robotic solutions, AI-based robotic solutions, the boiler controller systems. Boiler means steam generator. Sometimes we call it boiler also. Hmm? Analysis, like that. So in conclusion, we have seen, like, artificial intelligence has a great provide a good advantage for, data optimization, for construction and safety surveillance, operation support, decommissioning optimization, like design optimization and prediction, anomaly detection, plant diagnostics, digital twin, smart site. So all these can be the solutions based on these challenges can be given by the artificial intelligence. So these are the references from where the cases has been taken. So the interested one can also refer also to study into the detail. Okay. So thank you for listening me patiently. So in case of any doubts, I'll be happy to answer you. Sensors to communicate. Sensors to communicate by UDP protocol, depending on, like, wireless we don't use, but wireless can also be used. Generally, we don't use the wireless. Yeah. No, IoT also, wireless communication we don't do. Actually, this nuclear sector is very sensitive, and everything uh, needs to be, we have to follow the regulatory guidelines and the international practices. So, as per the standard, for example, our national regulatory body is Atomic Energy Regulatory Board. So, depending on he recommends, he gives the recommendations based on the international regulators. So, we have to ensure there should not be loss of data, and like those things needs to be ensured. So, generally, what we use And wireless sensors may be used in some small information system, which may not be very much sensitive to the with respect to the safety aspects. Yeah, we have the proprietary protocol basically because we don't rely on the others protocol. And we do have the proprietary operating system as well for the embedded system. We cannot use the third party operating systems. For display, it is okay. Windows or Linux we can use. But for embedded system, which is basically taking the decision to control the field devices, like opening the valve, closing the valve, measuring the sensor, the levels, you know. So for that, we do have our proprietary operating system. We cannot rely on the third party operating system. So there is an operating system division which is taking care of that. Okay. Uh, So thank you. Thank you for listening. Yeah.
Thank you, Lalit sir, for your wonderful session. So now I would request our training head, Dr. K.M. Rajan sir, to felicitate our guest. Thank you so much, sir. Participants, now we are having a tea break. After that, as per the schedule, actually, we have a hands-on session. So, like, all of you have your laptops? No. Sir, actually, in the mail we have put, sir. Okay. Sir, otherwise, can we have a visit of CTTC today? From tomorrow, we'll have the hands-on. Is everyone comfortable to bring the laptop, or else we can take you out to our lab as well? Like, which one would be comfortable? Second one is better. Okay, sir. We'll take you to our labs then. So today, can we have a visit of CTTC? Is that fine? Okay. Then we are just arranging that.